House cleaning is a difficult craft. For example, there is constant cat and dog activity in our house. Since the house is old, dust easily enters through the windows and door gaps. Cleaning is pure torture for us, with the Evolutionary Tree's work on one hand and 2 children on the other. Since finding someone to help with the cleaning is incredibly expensive, we are forced to turn to technology. Yes, I'm talking about robot vacuum cleaners, which are getting better and better every day, and whose market share is growing rapidly. We have used almost every brand in the last 6 or 7 years, but we have been using Roborock for the last 3 years. I've been wanting to tell you for a long time how the amazing technologies inside these robots work. But I kept postponing. Roborock has finally officially entered Turkey and reached out to us and made a video about it. He asked us if we would consider it. We jumped right in, but what I will tell in this video is entirely my own experience. I'll tell you about our own experience with these devices, their pros, cons, and the amazing science that goes on behind the scenes. I will also share my criticisms and the aspects I don't like towards the end of the video. If you are ready, let's get started. While doing his PhD in evolutionary algorithms at Texas Tech University, he decided to take the plunge and graduate directly from the computer science department to delve deeper into artificial intelligence. I decided to take lessons. The only problem was that, as someone with a mechanical engineering background, my software background was much weaker than my friends in computer science. Of course, when the courses are at doctoral level, no one teaches you programming or anything like that. On the contrary, it is assumed that you know several languages very well. However, I only knew one language at an advanced level. This language was a software called MATLAB, which was developed for engineers and was not even considered a language. Older members of this channel know that I had made videos explaining MATLAB in university classes. Anyway, the first course I took in the computer department was computer vision, which was about vision in computers, and the professor said that we had to finish 3 interconnected projects in order to pass the course. The first step of the project was as follows. A robot finds itself in an unfamiliar part of a map that it does not know. Let the robot travel between any 2 points in this environment without hitting any obstacles and, while doing so, create a complete map of the environment. So no matter what map the professor gives you and what obstacles he puts on that map, your robot will be able to go to every accessible place on that map, and at the same time map that environment. Hello, Rocky. Stop cleaning. Think about how you would do that. Of course, this is not a new problem in engineering. We call this SLAM, or simultaneous localization and mapping. Here are their top-of-the-line smart vacuum cleaners. When you put them in your house that they don't even know, this is essentially what they do. While cleaning your house on the one hand, they map it on the other. So how does it do this? There are actually a bunch of ways to do this, but I chose the simplest way I could think of in my PhD. I put a laser on top of my robot and shot a beam from it. The beam traveled across the room, hit a surface or obstacle and bounced back. Since the speed of the laser was constant and the speed was the speed of light, I could measure the time it took for the beam to travel back and forth to the wall. Infer distance and geometry. We call this method LiDAR, which is short for light detection and ranging. The version you might be more familiar with, the one used in the oceans, where light doesn't penetrate very well, but sound travels beautifully, sound navigation and ranging. Sonar, short for sound navigation and ranging. So sonar is done by sound, and LiDAR is done by light. Anyway, with a lot of effort I more or less managed to do it. But the problem was that my laser was fixed to my robot. So wherever my robot was pointing, my laser could go there too. Naturally, I had to rotate the robot around itself to get a 360-degree scan. And this was a tremendous waste of time getting where I was going. To solve this, I devised a system that fired lasers in 3 different directions at 120 degrees. But it wasn't perfect either. Also, since I was modeling the laser as a particle rather than a wave, I couldn't take advantage of the wave-like properties of light, such as interference and diffraction. I could only pick up very little of the information bouncing off the walls. The downside was that by the time I could code 100th of what I was doing in MATLAB, the computer science students had already finished this part in languages like C++ or Python and moved on to the second part of the project. We are young, we are ignorant. What am I? Anyway, I won't make it too long. As a result, I learned that sailing into waters where I didn't have a good foundation at the PhD level would waste my time, and I never took another computer science course after that. But still, even the effort I put in that term was a very good lesson for me. In the real world, they solved this problem I encountered very cleverly. For example, the cleaning robot we currently use is Roborock's SV Max and Ultra models. Look, there's a protrusion here. That's a turret, a tower. Inside this tower are the lasers and sensors used in LiDAR technology. Since the design inside this tower can rotate 360 degrees around itself, just like the turret of a tank, the robot can shoot beams in any direction and can collect 360 degrees of data from the room at any time, in any orientation. If your sensor is sensitive enough, you can gather incredibly detailed data by rotating the tower inside it very quickly. That's exactly what these robots do. In this way, they detect the walls and doors of your home and create a complete map of it. In the meantime, they can even distinguish whether a room is carpeted or parquet using the surface sensors underneath them. In this way, they can detect the boundaries of a room while learning what kind of cleaning needs to be done in that room. For example, they can lift this mop section up when walking on the carpet. In this way, its movement is not hindered. They return to the station to recharge. They can minimize friction by lifting both the mop and the broom section. But these robots take it a step further. Let's say you send your laser and detect an object in front of you that shouldn't normally be there. Will you go around it, add it to the map permanently, or clean up underneath it? It can't just be an object is approaching. You also need to be able to identify that object. Here, high-end robots like Roborock can take photos and videos of the objects they see, thanks to their RGB cameras and 3D light sensors on the front. Then, another subsection of computer vision. Object recognition algorithms come into play. I'll explain these to you in a video very soon. Don't forget to turn on channel notifications now if you don't want to miss it. But in short, this method is a photo you take, or it is based on extracting the boundaries, colors, and basic qualities of objects in video frames with the help of algorithms, and then running them through a machine learning algorithm. If your algorithm is trained on images of a large enough number and variety of objects, your robot can also understand which category of object it sees. Assume a baby, a cat, a dog, or a blob. For example, Roborock claims to be able to distinguish 73 different objects in this way. The more objects there are, the better you can determine what you should and should not do to them. If it's a baby or a pet, you can make it treat them more gently by pressing a button in the settings in the Roborock application. In addition, the robot can use this software too. Or it can also distinguish how dense and stubborn the dirt is and create a cleaning plan accordingly. These devices are getting smarter, so be careful with them. By the way, let me open a side note. One of my favorite features of this device is that you can use the robot like a remote control car by pressing the camera button right there. If it gets stuck on the floor, you can manually free it from there if you want, or you can easily do this when you need to look under your bed. Of course, I usually use it to play chase with the kids. Now let's get to the really important part. Our robot can learn our home and overcome obstacles, but its real job is, how does he do the cleaning part? There are two main pieces here: broom and mop. Yes, this robot can vacuum soft surfaces like carpets and hard surfaces like hardwood. But on top of that, thanks to his mop, it can also clean hard surfaces with water and detergent. This is very important because cleaning is not just about sweeping. I think it's a great thing that detergent and even hot water disinfection are involved. Meanwhile, the hot water part went to the robot for tasks such as charging it, emptying the dirt and grime it collected, and filling the detergent tank. It happens at the station. This station itself is actually a machine in itself. First of all, one of the main ways robots can find the station. The mapping I explained at the beginning, but even if you change the location of the station, the robot can understand it because there is an infrared frequency communication between the station and the robot. The Nest is constantly telling him to come, come. The robot can go in that direction by following those signals. The robot uses the station for many different purposes. For example, this is the container where the robot empties the dirt and grime it has collected. This container needs to be emptied at rare intervals of 6 to 7 weeks, and the bag needs to be changed every now and then. We fill the container here with water every few days, but this frequency can vary depending on usage. As the robot goes to and from the station, it takes some of this water and uses it to mop the floors. The detergent container is here. One filling lasts 2 to 3 months, but in my opinion, the most important thing is that this station can wash the robot's mop with hot water of 60 degrees. There is no constant bacterial accumulation on the mop. In fact, according to an independent analysis by TV Rainland, thanks to this mop cleaning performed with hot water, the rate of bacteria such as Staphylococcus aureus and E. coli can be reduced by 99.99%. This is really important in terms of cleaning also. I think the best feature of the station is that it can clean the base part, which collects the most dirt and drove us crazy in old models, by itself. Anyway, without getting too off topic, let's go back to how robots do the vacuuming job. Like all vacuum cleaners, smart vacuum cleaners also use an electric motor to suck up dirt and dust. This motor turns a propeller with the power it receives from the lithium battery of the vacuum cleaner, and a low-pressure volume is created inside the vacuum cleaner due to the movement of air by this propeller. 1 atmosphere outside the vacuum cleaner, that is, 101,325 pascals of atmospheric pressure, is created inside the vacuum cleaner. Since it has a higher pressure than this low-pressure area, the air starts to flow from high pressure to low pressure, pushing surrounding dirt and grime into the vacuum cleaner. The suction power of a vacuum cleaner is determined by how much the pressure created inside the vacuum cleaner differs from atmospheric pressure. If the vacuum cleaner can reduce the pressure inside the vacuum cleaner to 97,000 pascals, we subtract 97,000 from 101,325 and we obtain a suction power of 4,325 pascals, and 4,000 pascals is considered the standard for medium-level cleaning. Many simple vacuum cleaners in your home only have a suction power of 1,000-2,000 pascals. This latest model from Roborock sucks at 10,000 pascals, and thanks to this high pressure difference it can also remove larger or more stuck to the ground dirt and dust particles. But of course, the job doesn't end with just sucking. It is necessary to bring the dirt to the vacuum cleaner's mouth and spend enough time on the dirt if necessary. You may know it from house cleaning. Some dirt can be stubborn and you may need to scrub it for a long time to get it off the ground. Here are these robots. They use these side vacuums to pick up looser dirt. When they encounter more stubborn dirt, they try to remove it by spending more time on it. Of course, since they don't have infinite power, sometimes they can't suck it. Now, arm strength comes into play here. You shouldn't expect everything from the robot. Also, I think the biggest problem of these devices traditionally was the geometry problem. If you noticed, these devices are always in the shape of a circle. However, our circles, in other words, our homes, are generally square or rectangle. If you place a circle on the edge of a rectangle, and especially on its corner, you will see that there are huge gaps that the center of the robot cannot reach. That's why these tools always collected hair and dust on the edges and corners, because they couldn't reach there. But in this latest product from Roborock, and the brushes that collect dirt have a feature called Flexi Arm. When the robot approaches a wall or corner, this opens outward and washes the dirt and grime in those areas, which we can call blind spots, into the robot, and sucks it up. I think this is a pretty smart solution and it works pretty well. By the way, I think one of the most obvious areas where artificial intelligence has directly entered our lives is this robotic cleaning area, because this robot makes life a lot easier thanks to artificial intelligence. For example, our house is single-story, but there is a step inside, and so thanks to the robot sensors, it understands that there is a step there and does not fall and get damaged. There is nothing to be done about it not being able to go over this step for now. We place the robot that we want to clean on this side. There. But the good thing is that since these are not stupid like the old robots, they can keep different floors of the house as separate maps, understand which floor it is on and find their way accordingly. Another place where artificial intelligence is a part of the job is the various programs of this robot. You can choose when it will sweep a floor, how often it will mop, or you can run it in silent mode at night and set it to maximum settings during the day. Robot. It can also turn on the light in front of it to illuminate hard-to-see places while working at night. I think this is a very nice feature. But the robot also takes care of the needs of the house thanks to the support of artificial intelligence. Over time, it can learn when it gets dirtiest and what kind of routes it takes to cover the house most efficiently. Thus, its efficiency increases with each use and it starts to offer you smart cleaning modes. For example, when he needs to mop a large area, he can return and have his mop cleaned at the frequency he determines. So we went further afield. Cleaning performance does not gradually decrease, or you can adjust how often the transition between sweeping and mopping should occur. Even where. It also figures out which room it is and can act accordingly. For example, if you want, you can make it vacuum the bedroom more quietly. Of course, if he does something wrong, for example if there are rooms you don't want him to enter, you can create virtual walls on no-go zones, that is, areas where he shouldn't go, through the application. I won't bore you by going into all the details of the application here, but let me tell you that there is a pretty comprehensive control option. Anyway, there's actually a lot to talk about these robots, but I won't go into detail. I think what I've explained so far has given you a better understanding of how complex hardware and software these robots now have. Now I would like to talk about a few points that we still don't like about these robots or that you might be concerned about. For example, one of the things we don't like about it is necessary to change the entire bag where the dirt is collected every once in a while. Well, this creates an extra expense if it weren't necessary to do this, and it would be much better if the dirt was emptied directly into this chamber like in the old robots and we could just clean it. Also, I think these brushes wear out very quickly, and just like many robots we've used so far, after a while it starts to leave cat and dog hairs on the carpet in balls instead of sucking them up. Although strangely, it is extremely easy to manually collect these balls later. So even this is better than not having a robot at all. But it still feels like we need to find a more robust solution for it. Of course, if you change the brushes, we are back to our old self. Of course, every material has a lifespan, and since we run these robots more often than a normal one, we need to change the brushes a little more often. But there's also an expense, so be aware of that. Another common concern I hear from people is that they think robot vacuum cleaners can't be as good as human cleaning. So again, they think they can't take our business. All joking aside, I think this is a justified concern and I think robot vacuum cleaners will not be able to fully imitate the cleaning that a person can do with their own labor for many years to come. But in my opinion, that's not exactly the job of these robots anyway. Rather, they aim to handle the rough part of the job that has to be done constantly and to reduce the frequency of the cleaning you have to do. Besides, cleaning isn't just something that can be done on the ground. After all, this job has windows, kitchen surfaces, furniture. These are ultimately helpers. We shouldn't forget that. Another problem is that no matter how smart they are, they still get stuck somewhere frequently. So if you don't leave anything on the floor at home, maybe it's okay. But I'll throw in a piece of paper if you forgot it. Those types of things can get stuck in this main brush and stop the robot. In that case, you need to go and rescue the robot and remove the stuck things. Noise is another issue. They are much quieter than most traditional vacuum cleaners, though. For example, the noise of this model in balanced mode is around 67 decibels. That is, about the same as two people having a normal conversation or the noise of a dishwasher. Since we generally run it at maximum, it runs much noisier. And for example, it can interrupt conversation during meals. But in that case, we can tell the robot to skip this room. He also walks away, walking slowly, to the next room. By the way, I forgot to mention, but hello Rocky. After saying this, you can give dozens of voice commands such as start cleaning, return to the station, take a break, etc. These commands don't actually work too badly, but you have to say them in very specific ways. These devices will be called GPT in the future. When artificial intelligence at the level arrives, it will truly be legendary. Finally, as with every device, the battery life of these devices is good, slightly less than advertised, because battery life statistics are tested and announced in very ideal situations and at the lowest settings. For example, it is said that this device can clean for up to 3 hours. We can have the cleaning done in 1 to 1.5 hours at most, with the settings we want. The maximum time we have been able to achieve so far has been around 110 minutes, at settings that are lower than we want. Although all of these numbers I mentioned, if we include the suction power, are higher than any robot we've used so far. I have to say that too, but still, people want them to clean for longer. Fortunately, when the battery is low, the device goes to charge, and depending on the setting you choose, it either continues where it left off or starts cleaning from the beginning. There you have it. As you can see, like no other modern technology, these devices are not things that can work 100% flawlessly without any glitches. Of course, they have some troublesome aspects, but the existence of these robots, in my opinion, it is definitely better than their absence. Doing your own house cleaning on top of what the robots do is much easier than cleaning the whole house. Of course, your approach to this subject may be different depending on your understanding of cleaning. After all, I can only tell you about my own experience, but I can't tell you the evolution of these devices over the years. And seeing the increase in accuracy rates is definitely one of the easiest ways to see the full speed ahead of science and technology. If you're curious, I'll leave a few Roborock models that you can buy below. They all have their own advantages and disadvantages. I recommend you research them as well. My goal here is not to tell you to buy this or that model, but to explain the technology behind these increasingly smart devices, and to give you a little insight into what they can do now that they couldn't before. The ball is now in your court. By the way, if technology videos interest you, don't forget to subscribe to our second channel, Everin AAC Technobulim. See you in the next video. Bye.